Good morning, class. Today, we are launching our quarter one performance task, and it is a very exciting one because it turns you into real world problem solvers for our local community. And the title of our performance task number one for the quarter one is the Barangay Tricycle Terminal and Crossing Layout, in which the focus is the infrastructure. So think about your own school gate during dismissal time. What happened? It gets crowded, right? Tricycles are trying to park, students are trying to cross, and it creates a massive bottleneck. Well, in this task, you are stepping into the shoes of a student volunteer mapper and safety draftsman. Your client is a barangay captain and the committee on transportation. They have asked you to design a geometric blueprint for a newly designated tricycle terminal and pedestrian crossing. And your ultimate goal is to use the geometry we've learned this quarter: primitive geometry, transversal, and linear paths, to mathematically prove that your design keeps everyone safe and eliminates dangerous blind spots. Now, let's look at what you actually need to hand in. You aren't just drawing a random picture of a street. You are producing a barangay transit layout blueprint, which has two distinct requirements. First, a precise geometric schematic. This means you will use points, lines, rays, segments, and angles. Every single one of these elements must be labeled with exact mathematical notations we learned in class. Second, a transversal system analysis. You must provide a step-by-step mathematical explanation, essentially a geometric proof, proving the degree measures of your angle zones to justify why your crossing distances are safe. To make sure your design looks like highly professionals, I highly encourage you to use geometric software like GeoGebra or a precise physical drafting toolkit. Remember, the Barangay Council needs to be able to read it clearly. Let's talk about how to approach the map without me doing the project for you. I want you to visualize how a road system works through the lens of geometry. When we look at parking bays, they are usually lined up next to each other. What geometric relationship do these divider lines have? They are parallel. Think about how we write that mathematically. If you name one line L sub 1 and another line L sub 2, you need to explicitly state and label L sub 1 parallel to L sub 2. Now, a pedestrian lane has to cut across the road. What do we call a line that intersects two or more parallel lines? A transversal. When that transversal cuts across your parallel parking lines, it creates eight distinct angles. Your job in this project is to analyze those angles. For example, if you decide your crosswalk intersects the curb at a specific angle, what does it mean for the alternate interior angles? What does it mean for the corresponding angles? You cannot just you cannot just guess the measurements. There. You must use our geometric postulates and theorems, like the corresponding angles postulates or the alternate interior angles theorem, to back up your math. Also, pay attention to definitions. If your parking slots have a definitive beginning and end, or they lines, rays, or line segments, make sure your symbols reflect that. A line AB is very different from a segment AB. Here is where your creativity and critical thinking come in. The Barangay Council isn't just creating you and math accuracy, they care about safety. When a tricycle driver is sitting in a parking bay, their line of sight can be modeled as a geometric ray. If you place a parking bay directly against a crosswalk, does that ray of sight get blocked by another vehicle? If yes, you've just created a blind spot and a student could get hurt. In your design, think about how you can use spacing, angles, or no parking zones, which you can represent as specific geometric segments to clear those spotlights, blind spots rather. You need to explain in your final write-up why the angles you chose ensure that both drivers and pedestrians have a clear, safe line of sight. So before you begin, let's look at the rubric together so you know exactly how to get a perfect score of 4, which is the goalkeeper. For the math accuracy, the correct question is: did you calculate your geometric properties correctly? To get 4, every calculation, plotted coordinate point, and geometric or triangle ratio you use to design your transit system must be 100% accurate. The downside: minor slips in layout drop you to a 3. Fundamental errors that distort your actual physical dimensions, will drop you to a 2 or a 1. Second criteria, using math symbols. The correct question: did you label your blueprint using proper geometric notation? To get a 4, you must use correct formal notation uniformly across the plan. This means distinguishable align AB from align segment AB, and properly writing notations for rays, points, and angles. The downside: forgetting symbols or accidentally swapping them makes a technical drawing look unscholarly, dragging the score down. For the third criteria, logic and proofs. Can you mathematically justify your layout's design? To get a 4, your written defense must be a flawless step-by-step deductive geometric proof. Every single structural claim you make about safety or layout must be paired with an official geometric postulate, definition, or theorem. The downside: skipping logical steps or using circular reasoning means you are just guessing rather than proving, lowering your score. The fourth criteria, drawing and tech skills. How clean, precise, and professional is your visual layout? To get a 4, your project needs to display master level execution. Lines must be perfectly straight, angles must be drawn to scale, and centers must be precisely mapped out using either digital software like GeoGebra or manual drafting tools. The downside: crooked lines, unskilled elements, or a messy, rushed presentations will significantly reduce points in this category. For the fifth criteria, safety and community planning. Thus, your design actually solve the real-world traffic problem safely. To get a 4, your blueprint cannot just look pretty. It has to function effectively. You must use geometric properties like angles of approach and transversals to intentionally engineer out any potential blind spots for tricycles and ensure maximum safety for crossing students. The downside: mismatching spacing regulations or creating a layout that leaves pedestrians vulnerable makes the plan unsafe and drops you into the lowest tiers. For the last criteria, precision and pride in my work. Thus, the overall project reflect excellence, dedication, and academic integrity. To get a 4, this category evaluates your personal character and care. The work must be exceptionally organized, meticulously tidy, and stand as an honest reflection of your own highest effort and academic pride. The downside: submitting an incomplete, wrinkled, Or untidy page shows a lack of discipline and effort, which will result in a 2 or 1. So once again, this is our performance task number 1 for the quarter 1, the Barangay Tricycle Terminal and Crossing Layout. That's all.